The blizzard had been raging for 3 days with temperatures at 40 below zero, and every prospector within 10 miles was burning through their winter firewood in a desperate fight to stay alive. Inside his strange tower cabin, Fergus MacAllister sat comfortably by a single fire that had been lit only once that morning, while the massive stone chimney at the building's heart radiated heat that would last until dawn. Before we continue, let us know where you're watching from, and if engineering stories like this fascinate you, hit subscribe because tomorrow's frontier innovation is even more unbelievable than this one. The storm hit the Montana Territory on March 11, 1852, without warning. Fergus MacAllister and Duncan Reed had been working their claim along a tributary of the Madison River for 2 seasons, pulling enough gold from the gravel bars to make the brutal winters worthwhile. Their cabin stood in a small clearing surrounded by pines, a standard single-room structure built the previous year in 4 days. Notched logs at the corners, mud and moss chinking between the gaps, a simple door on leather hinges, one small window covered with scraped hide, and a basic stone fireplace that drew smoke adequately but provided minimal heat. It was typical frontier construction, identical to dozens of other prospector shelters scattered throughout the territory. When the wind began picking up that afternoon, neither man thought much of it. March storms were common. They had plenty of firewood stacked against the cabin's north wall, enough dried meat and flour to last 2 weeks, and a solid roof overhead. By evening, the temperature had dropped 20 degrees and snow was falling heavily. By midnight, the wind was screaming through the valley and the temperature had fallen below zero. The cabin's weaknesses revealed themselves quickly. The leather door hinges allowed the door to rattle and shift, creating gaps that admitted icy wind. The hide window covering flexed and billowed with each gust. Most critically, the mud chinking between the logs had dried and cracked over the winter, and now wind pushed through dozens of small gaps in the walls. Fergus and Duncan fed the fire constantly, burning through wood at an unsustainable rate. But the heat simply escaped through the walls and roof as fast as they could generate it. By the second day, they had burned through half their firewood supply. The temperature outside had dropped to 30 below zero. Inside the cabin, even standing next to the fire, their breath formed clouds. They wrapped themselves in every blanket and fur they owned, and took turns sleeping in brief shifts, one man always tending the flames. Duncan developed a cough that worsened through the day. By the third morning, they had less than 2 days of firewood remaining, and the storm showed no signs of breaking. Duncan's cough had turned harsh and painful. He was shivering violently, even wrapped in furs next to the fire. Fergus kept the flames burning as high as he dared, knowing they would run out of fuel, but unable to watch his partner freeze. On the afternoon of the third day, Duncan's shivering stopped. Fergus thought initially this was a good sign. He was wrong. Duncan had entered the final stages of hypothermia. His body was shutting down. By evening, Duncan Reed was dead frozen despite being less than 5 feet from a roaring fire. The storm broke the next morning. Fergus buried Duncan on a hillside overlooking the creek where they had worked together. He spent that night alone in the cabin that had killed his partner, unable to sleep, staring at the gaps in the walls where wind still whispered through. Duncan had not died from lack of supplies or injury or dramatic wilderness threat. He had frozen to death inside a shelter specifically built to protect against cold. Fergus MacAllister began that night an obsession that would consume the next 18 months of his life. Fergus spent the spring of 1852 working his claim alone, but his mind was not on gold. Every evening, after hauling gravel and running the sluice, he sat in the cabin that had killed Duncan and studied how heat moved through the space. He watched smoke from the fire drift toward the ceiling and disappear through gaps in the roof. He felt cold air flowing along the floor even when the fire burned hot. He placed his hand against the log walls and felt how quickly they lost the day's warmth once the sun went down. The cabin was not a container for heat. It was a sieve that let warmth escape as fast as he could generate it. In late April, he visited William Tate's claim 8 miles downstream. Tate had built his cabin the same year using identical methods. Fergus asked to examine the structure carefully. Tate thought the request strange, but allowed it. Fergus spent an hour inspecting the walls, testing the chinking, examining the corners where notched logs created small gaps, and measuring the door frame. Tate's cabin had the same fundamental problems. Heat escaped through dozens of tiny openings. The fireplace drew air from inside the cabin rather than from outside, creating a constant draft that pulled warm air up the chimney. The single-room design meant the entire space had to be heated, even when only one person occupied it. Over the next month, Fergus visited 5 other prospector camps within riding distance. Every cabin showed the same pattern: fast construction using notched logs, minimal chinking that dried and cracked, simple fireplaces that consumed heat rather than radiating it, large single rooms that were impossible to heat efficiently in severe cold. The men who built these cabins accepted cold winters as inevitable. They burned enormous amounts of firewood and simply endured the discomfort. If someone froze, it was considered bad luck or poor preparation, not a failure of design. In June, Fergus rode to Denver to sell his spring gold and buy supplies. Instead of spending 2 days conducting business and returning immediately, he stayed for 2 weeks. He studied buildings, the brick merchant houses with their thick walls that stayed cool in summer heat, the stone bank building that maintained steady temperature regardless of outside conditions, the warehouse with its massive timber frame that supported weight through careful joinery rather than simple stacking. He watched carpenters working on a new hotel and paid attention to how they reinforced corners and built door frames that could not shift or warp. He bought books on masonry and basic engineering from a store that catered to mining operations. The books were intended for building stamp mills and ore processing facilities, but the principles applied to any structure. Heat moved from warm areas to cold areas. Mass absorbed and held heat. Air circulation created convection currents. Insulation slowed heat transfer. These were not complicated concepts, but almost no one applied them to frontier housing. Fergus returned to his claim in late June with a head full of ideas and a determination to build something that would not kill its occupant. William Tate saw him unloading unusual supplies and asked what he was planning. Fergus tried to explain thermal mass and heat retention. Tate looked at him like he had gone mad from grief and loneliness. Fergus began construction in early September of 1852 when most prospectors were making final preparations for winter. The location he selected was unusual. Most men built near water for convenience. Fergus chose high ground 50 yards from the creek on a slight rise with clear sight lines and good drainage. William Tate rode over to watch the first day of work and was baffled to see Fergus digging trenches instead of cutting logs. The trenches formed a Y shape, 2 parallel rectangles meeting at a central point. Each rectangle measured 12 feet by 20 feet. The trenches were 18 inches deep and 2 feet wide. Fergus spent 3 days digging through rocky soil, then began hauling stones from a talus slope half a mile away. The stones were flat pieces of granite and limestone, some weighing over 100 pounds. He loaded them onto a crude sledge pulled by his mule and dragged them to the site, one load at a time. Tate watched this process for a week before riding over to ask directly what Fergus was building. "A cabin," Fergus replied. Tate pointed out that cabins were made of logs, not stones. Fergus explained he was building a foundation. Tate said foundations were unnecessary and a waste of time when a man could simply set logs on level ground. Fergus continued fitting stones into his trenches without argument. The foundation took 6 weeks to complete. Fergus fitted each stone carefully, using smaller rocks to fill gaps and packing clay between layers. He built the foundation walls 3 feet high, creating a stone perimeter that outlined his Y-shaped plan. At the junction, where the two rectangles met, he built a square stone pillar 4 feet on each side, rising 5 feet above ground level. This would be the base of his chimney. Other prospectors began stopping by to see what MacAllister was doing. Hugh Morrison called it a castle foundation. Malcolm Grant asked if Fergus was planning to defend against an army. The general consensus was that Fergus had lost his mind from spending too much time alone. 6 weeks of back-breaking labor to create a foundation for a simple cabin made no sense. A man could build an entire functional cabin in 4 days. Fergus had spent 42 days just laying stones. William Tate was more direct. He told Fergus that winter was approaching and he had no shelter built. The stone foundation would not keep him warm. If Fergus wanted to survive, he needed to stop this foolish project and build a normal cabin immediately. Fergus thanked him for the concern and began laying the first floor walls. The first floor walls were stone, continuing upward from the foundation. Fergus built them 8 feet high, creating 2 stone rooms connected by the central chimney pillar. Each room had a door opening and 2 window openings. The walls were 2 feet thick, fitted stone on both faces with rubble and clay filling the gap between. This was not cabin construction. This was fortress building. The community name for the project evolved from curiosity to mockery. They called it MacAllister's Folly. Fergus called it survival. The central chimney pillar was Fergus's obsession within an obsession. He spent 2 full weeks on this single element, while other prospectors shook their heads at the waste of effort. The base measured 4 feet square, larger than most cabin fireplaces by a significant margin. Fergus built it with the flattest, densest stones he could find, fitting them so tightly that mortar gaps were minimal. The pillar rose through what would become all 3 floors of his structure, positioned precisely at the junction point where his 2 wings met. William Tate visited during the chimney construction and asked why anyone needed a chimney that size. Fergus tried to explain thermal mass. Stone absorbed heat from fire and held it for hours, radiating warmth long after flames died. A small chimney heated quickly but cooled quickly. A massive chimney took longer to warm, but once heated would radiate for half a day. Tate pointed out that massive also meant heavy and difficult to build. Fergus acknowledged this but continued laying stones. The chimney was not simply large, it was engineered. Fergus built 2 separate flues inside the stone mass, one serving each wing of his Y-shaped cabin. The flues were lined with fire brick he had purchased in Denver at considerable expense. Between the 2 flues, he left a solid stone core that would absorb heat from both fires. This central mass would become a heat battery, storing thermal energy and radiating it into both wings simultaneously. At ground level, he built 2 fireplace openings, one facing into each stone room. The openings were smaller than traditional fireplaces, designed to radiate heat efficiently rather than simply draw smoke. He angled the back walls of each fireplace forward, creating surfaces that would reflect heat into the rooms. He built smoke shelves inside each chimney, horizontal ledges that prevented downdrafts and reflected heat back down into the living spaces. The stonework required precision Fergus had taught himself through trial and error. Each stone had to bear weight evenly. Gaps had to be minimal to prevent heat loss. The flues had to draw properly without creating excessive draft that would pull heat up and out. He worked slowly, testing each section as he built upward. Several times he tore out entire days of work because the fit was not perfect or the alignment was slightly off. By late October, the chimney rose 15 feet above ground level, passing through where the second floor would eventually be. Other prospectors had finished their winter preparations. Cabins were chinked and provisioned. Firewood was stacked. Fergus had 2 stone rooms with no roof and a massive chimney rising from bare ground. Malcolm Grant told him directly that he would freeze to death before Christmas. Hugh Morrison offered to let Fergus share his cabin for the winter. Fergus declined politely and began cutting logs for the second floor. The community opinion was unanimous. MacAllister was building something ridiculous, impractical, and unnecessarily complex, a monument to grief and isolation. No one understood that Fergus was not building a cabin. He was building a thermal machine designed to keep a man alive when 40 below zero tried to kill him. The second floor construction began in early November of 1852, dangerously late in the season. Most prospectors were already hunkered down for winter. Fergus was cutting logs. He selected trees with obsessive care, rejecting any with significant taper or irregular shape. He wanted logs as uniform as possible, approximately 10 inches in diameter. William Tate watched him pass over perfectly serviceable trees and asked what he was looking for. "Straight grain and consistent diameter," Fergus replied. Tate said he was wasting time being particular about logs that would all look the same once stacked. Fergus stripped every log completely using a draw knife, removing all bark. The process was backbreaking. Each log required hours of work. Tate asked why he bothered, since bark provided extra insulation. Fergus explained that bark created irregular gaps between logs. Stripped logs of consistent diameter could be fitted tightly with minimal chinking. Tate rode away shaking his head. The second floor walls went up using horizontal log construction, traditional notched corners, but Fergus modified the standard approach. He cut his notches deeper and more precisely than typical frontier practice, ensuring each log seated firmly, without gaps. Between each log, he packed a mixture he had developed over the summer: clay, horsehair, and boiled pine resin combined into a compound that dried flexible and waterproof. The preparation took days. The application took weeks. Standard mud chinking could be slapped between logs in hours. Fergus's method required careful packing and smoothing. The second floor layout matched his ground plan. 2 rooms connected at the central chimney. Each room measured 12 feet by 20 feet. The chimney passed through the center of both, already built to this height from below. Fergus installed floor joists and planking, creating solid floors above the stone first level. He built interior stairs in each wing, connecting ground and second floors. The feature that drew the most mockery was the balcony system. Fergus extended floor joists beyond the wall line and built balconies around both wings at second floor level. The balconies were 6 feet deep, supported by 3 vertical posts each, with horizontal log railings. Then he built roofs over these balconies, creating covered outdoor spaces. William Tate called it the most foolish addition yet. Who needed fancy porches in the wilderness? Fergus tried to explain wind buffering. The roofed balconies created dead air space between the exterior and the cabin walls. Wind would hit the balcony roof and railings first, losing energy before reaching the actual walls. The air gap would insulate the living spaces. Tate said that was the most complicated explanation for a porch he had ever heard. By December, the second floor was enclosed and roofed temporarily with canvas and poles. Fergus moved his bedroll and supplies into one of the second floor rooms and spent his first night in the unfinished structure. The stone chimney radiated enough residual heat from the day's work fire to keep the space barely tolerable. It was not comfortable, but it was survivable. Outside, the temperature dropped to 15 below zero. Fergus slept in relative warmth and began planning the third floor. Spring of 1853 arrived before Fergus completed the third floor. He had survived the winter in his partially finished structure, burning far less firewood than his neighbors, despite having incomplete walls. William Tate noticed this, but attributed it to Fergus spending more time cold rather than any efficiency in the design. The reality was different. The stone mass of the first floor and central chimney stored and radiated heat so effectively that Fergus maintained comfortable temperatures with a single fire per day. The third floor construction followed the same horizontal log pattern as the second floor. 2 rooms, each 12 feet by 20 feet, connected by the central chimney that now rose through 3 complete stories. Fergus built solid plank floors and installed stairs connecting the second and third levels. The layout was becoming clear. A man could live on any floor depending on conditions, moving up or down to find the most comfortable temperature zone. The most unusual feature was the gable wall treatment. The third floor had a steep roof, creating triangular gable ends on each wing. Instead of closing these gables with horizontal logs or solid planking, Fergus used vertical logs spaced 3 inches apart. He set the logs into the top wall plate and the roof ridge beam, creating what looked like a fence built into the wall. William Tate visited during this phase and asked if Fergus had run out of materials. Why leave gaps in the walls? Fergus explained ventilation and moisture management. Heat rising from below would accumulate in the third floor. Without ventilation, moisture from cooking and breathing would condense on cold surfaces and rot the wood. The vertical gaps allowed hot, moist air to escape while preventing rain and snow from entering. The 3-inch spacing was too narrow for animals, but adequate for airflow. Tate said it looked unfinished. Fergus said it was precisely as intended. Notably, the third floor had no balcony or porch. The walls rose directly to the roofline without exterior extensions. Fergus explained that the third floor would be the warmest space due to natural heat rise. It needed no additional wind protection. The second floor balconies protected the main living quarters. The first floor stone walls needed no protection at all. Tate said the asymmetry looked ridiculous. Fergus continued building. The roof construction took 6 weeks. Fergus built steep gables, perfect for shedding snow. He used heavy ridge poles and closely spaced rafters, then covered everything with split planks overlapped like shingles. Over the planks he laid birch bark in multiple layers, then applied clay mixed with more horsehair and pine resin. Finally, he laid sod, living grass, and roots that would seal and insulate the entire structure. The roof was heavy enough to require the robust wall construction below. By September of 1853, the tower was complete. 3 stories tall, Y-shaped, with a massive stone chimney rising 6 feet above the peak. The community name had evolved. They no longer called it MacAllister's Folly. They called it the Ridiculous Tower Cabin. Fergus moved his belongings into the second-floor east wing and prepared for winter, confident in what he had built, but untested by true crisis. The winter of 1853 to 1854 was Fergus's first complete season in the tower cabin. He established routines quickly. Morning fire in the east wing second-floor fireplace built with carefully selected dry wood. The stone chimney absorbed heat throughout the morning. By afternoon, even with the fire reduced to coals, the chimney mass radiated warmth that kept the room comfortable. Evening fire for cooking, then banking the coals before sleep. The residual heat in the stone carried through the night. Fergus discovered the system worked better than he had calculated. The massive chimney core, heated from both wing fireplaces over months of use, retained baseline warmth even in the coldest weather. The stone first floor absorbed ground heat and daytime sun through the small windows, adding thermal energy to the system. The second-floor balconies created dead air buffers exactly as intended, reducing wind contact with the walls. The third floor became a heat reservoir, warm air rising and accumulating in that upper space. He developed a temperature management technique based on floor selection. Moderate cold, he lived on the second floor. Severe cold, he could retreat to the third floor where accumulated heat made the space almost uncomfortably warm. Extreme cold, he could close off the unused west wing entirely and concentrate all heat in the east wing, effectively halving the volume he needed to warm. His firewood consumption was remarkable. William Tate burned approximately 12 cords of wood that winter, feeding his single-room cabin's fireplace constantly to maintain barely tolerable temperatures. Fergus burned 4 cords total. His neighbors noticed this, but had explanations that did not require admitting his design worked. MacAllister was simply tougher, more willing to endure cold, or he was lying about his consumption. or he had found an unusually efficient wood source. In January, a cold snap brought temperatures to 35 below zero for a week. Fergus monitored his system carefully. Single morning fire banked through the day. The stone chimney radiated stored heat for 14 hours before dropping below comfortable levels. Evening fire restored the heat. He slept warmly under a single blanket, while William Tate, 3 miles away, huddled under firs next to a roaring fire that barely kept his cabin above freezing. Malcolm Grant visited in February and was surprised to find Fergus's cabin genuinely warm. He asked directly how much wood Fergus burned daily. 2 fires, Fergus said, morning and evening. Grant did not believe him. His own cabin required constant feeding just to survive. He examined the stone chimney and admitted it held heat impressively, but said the design was still impractical. The labor invested could have been spent mining gold. Spring arrived without crisis. Fergus had proven to himself that his thermal engineering worked. The tower cabin maintained comfortable temperatures with minimal fuel in conditions that made standard cabins barely survivable. But the prospecting community remained unconvinced. One easy winter was not proof. The tower was still ridiculous, still impractical, still a monument to obsession. What Fergus needed was a true test, a crisis that would demonstrate beyond argument the difference between engineering and hope. That test was coming. The storm arrived on February 9, 1855, with a violence that caught every prospector unprepared. The sky had been clear at dawn. By noon, wind was howling down from the north, and temperature was dropping fast. By evening, the blizzard was fully developed, with winds sustained at 40 miles per hour and temperature at 20 below zero. By midnight, the temperature had reached 40 below and was still falling. Robert Drummond's cabin stood 4 miles from Fergus's tower. It was typical construction, built in 5 days 2 years earlier. Good chinked walls, solid roof, decent fireplace. Drummond was experienced and well-provisioned. He had 10 cords of firewood stacked outside and plenty of supplies. When the storm hit, he began feeding his fire heavily, keeping flames high to maintain interior warmth. By the end of the first day, he had burned through what should have been 4 days of wood. The problem was heat loss. Wind found every tiny gap in his chinking and exploited it. Cold air flowed in along the floor. Warm air escaped through the roof. His fireplace drew enormous amounts of air, creating draft that pulled heat up the chimney. He wrapped himself in furs and stayed within 5 feet of the fire. But even there, his breath formed clouds. On the second day, his chinking began failing. The mud and moss dried and cracked in the extreme cold, creating larger gaps. Wind pushed directly through his walls in visible streams. He stuffed gaps with spare clothing and blankets, sacrificing insulation for structural sealing. William Tate's situation was worse. His cabin was older, the chinking more deteriorated. By the second evening, he was burning wood as fast as he could split it, and the interior temperature was still dropping. He burned furniture for additional fuel. He burned tools. He burned everything that was not essential for survival. On the morning of the third day, his firewood was gone. He had perhaps 6 hours of burnable material left, then nothing. The storm showed no signs of breaking. Malcolm Grant and Hugh Morrison shared a cabin 6 miles from Fergus. Their situation was better because they could take turns maintaining the fire and body heat from 2 men helped. But they were still burning through their wood supply at an unsustainable rate and losing the fight against cold that penetrated every wall. At the tower cabin, Fergus experienced a different storm entirely. He had lit his morning fire in the east wing on the first day and maintained it through the afternoon. By evening, the stone chimney core was thoroughly heated. He built up the evening fire, banked it heavily with coals, and went to sleep. The wind howled around the tower, but the roofed balconies deflected the worst blasts. The stone first floor remained stable, almost warm from retained heat. The second floor stayed comfortable from chimney radiation. Fergus woke on the second morning and found the room temperature had barely dropped. He built a moderate fire, not for survival, but for comfort and cooking. His firewood consumption remained normal. Outside, men were fighting desperately against cold that would kill them. Inside the ridiculous tower, Fergus was warm. On the afternoon of the third day, Fergus heard pounding on his door. He opened it to find Robert Drummond barely standing, covered in frost, shaking violently. Drummond's cabin chinking had failed completely during the night. Wind blew directly through his walls. He had burned his last firewood at dawn and fled his shelter before hypothermia became irreversible. The 4-mile walk to Fergus's tower had nearly killed him. Fergus pulled him inside and sat him near the fireplace. Drummond stopped shaking within 20 minutes, something that would have been impossible in his own cabin, even with a roaring fire. He stared at the stone chimney, feeling heat radiate from its mass. He touched the interior walls and found them merely cool, not frozen. He asked how much wood Fergus had burned. 2 fires daily, Fergus said, same as normal. Drummond did not understand how that was possible. An hour later, William Tate arrived, having made the 3-mile journey from his cabin in desperation. His situation had been identical to Drummond's. No firewood remaining, cabin too cold to survive another night, the tower his only option. Tate had openly mocked this structure for 2 years. Now he sat inside it, warm for the first time in 3 days, unable to deny what he was experiencing. Fergus explained the system while preparing food. The stone chimney core weighed several tons. Heating that mass required sustained fire over weeks, but once heated, it held thermal energy for days. The stone first floor acted similarly, absorbing and storing heat from both ground temperature and winter sun through the windows. The dual-wing design meant heat from the central chimney served both spaces efficiently. The Y shape created wind shadows where the wings met, reducing direct wind pressure on the walls. The roofed balconies on the second floor created an air gap that insulated the living quarters from direct wind contact. Tate asked about the third floor. Fergus led them up the interior stairs. The third floor was noticeably warmer than the second, heat having risen and accumulated in that space. Even with minimal fire below, the temperature was comfortable. Drummond pointed out that this violated everything prospectors understood about heating cabins. Upper spaces should be colder because heat escaped through roofs. Fergus explained that heat escaped through gaps and poor insulation, not through solid, well-built structures. His roof was multiple layers of wood, bark, clay, and sod. Heat rose but could not escape. The storm finally broke on the 4th morning. Tate and Drummond returned to their cabins to assess damage and salvage what remained. Both structures had suffered serious chinking failure and would require extensive repair. Both men had burned through most of their winter firewood in 3 days. Fergus's tower had consumed perhaps 1/10 of 1 cord total during the entire storm. Word spread quickly through the prospecting community. MacAllister's ridiculous tower had kept 3 men comfortable during a storm that nearly killed everyone else. The tower was no longer ridiculous. It was proven. But few were willing to replicate the months of brutal labor required to build one. Spring of 1855 brought a subtle shift in how other prospectors regarded Fergus MacAllister. The mockery stopped. Men who had called his tower ridiculous now asked detailed questions about stone chimney construction and thermal mass principles. William Tate spent 2 days at the tower in April, taking measurements and sketching the Y-shaped floor plan. He talked about building something similar for the next winter, but talk was different from action. Tate's enthusiasm faded when he calculated the actual labor involved. 6 weeks for the stone foundation, 8 weeks for the first floor walls and chimney core, 10 weeks for the second floor with its roofed balconies, 6 weeks for the third floor and roof, 30 weeks of brutal physical labor working alone before the structure was habitable. A standard cabin took 4 days. Tate rebuilt his old cabin with better chinking and accepted that he would burn large amounts of firewood. It was easier than building a tower. Robert Drummond asked if he could winter at Fergus's tower, offering to pay in gold or labor. Fergus agreed, and for the winter of 1855 to 1856, 2 men occupied the separate wings. Drummond experienced firsthand how the dual wing system worked. Each man maintained his own fireplace and living space, but both benefited from the shared central chimney mass. The arrangement worked well. Drummond told other prospectors that the tower was the warmest shelter he had ever occupied, but admitted he would never build one himself. A few elements of Fergus's design spread through the community. Prospectors began using stone for fireplaces more extensively, building larger masses that retained heat longer. Some tried mixing horsehair and pine resin into their chinking compounds. Hugh Morrison built a small stone foundation for his new cabin, raising it above ground level for drainage. But no one replicated the complete system. The tower remained unique. The Montana gold deposits began playing out in the late 1850s. Prospectors moved to new strikes in Idaho and Colorado. Fergus stayed until 1860, then sold his claim and moved to Oregon's Willamette Valley. He bought land, built a small house using stone foundation and efficient fireplace design, and lived quietly. He married in 1862, raised 3 children, and worked as a stonemason and carpenter. His past as a prospector rarely came up in conversation. The tower cabin remained standing. Travelers used it as a way station through the 1860s and 70s. The stone construction and solid roof kept it intact long after standard cabins rotted and collapsed. Men sheltering there during winter storms remarked on how little firewood was needed to heat the space. Some carved their names into the balcony posts. No one knew the builder's name or story. Fergus MacAllister died in 1881 at age 59 in his sleep, in the small Oregon farmhouse he had built for his family. He was buried in a cemetery outside Salem. His gravestone made no mention of the Montana Territory or the tower that had proven engineering could triumph over extreme cold. The tower itself stood for another 20 years before finally succumbing to time and weather, its stones scattering across the Montana hillside where obsession had once defeated 40 below zero.